Hi. Okay. So what I'm going to do, I'm going to show you my chapter 6 assignment in R. So the first thing we're asked to do is to create a scatter plot between hours and essay. So you're going to run that. Run here. My scatter plot was up here already, but that's just essentially what I got. So this is our scatter plot between hours and essay. Going to minimize that. So now we're asked to, hold on, let me go back up here. Okay, so now we're asked to conduct a Shapiro-Wilks test to check whether the data are parametric. So essentially, a Shapiro-Wilks test is a test of normality to make sure that our data, essentially to make sure that our data is normally distributed. So we're going to run this test, well, these two tests. Okay, so from our test on essay, we see that we have a non-significant p-value of 0.5177. And we have also for our hours, we have a non-significant p-value of 0.6615. So given that these two tests have provided us a non-significant value, this means that each of our data is normally distributed. So there's no deviation at all from normality or from normal distribution, essentially. So this is good. So, well, it's good for what we want to do next. So given our answer, we're also asked, so what type of correlation do we run? And also it asks one-tailed or two-tailed and why. So the correlation we're going to run is a Pearson correlation, and we're going to run it as one-tailed. We're going to run it as one-tailed because if you look back at our assignment, the student is trying to test whether there's a positive relationship between time spent doing an essay and the mark received. So given this right here, we have a directional hypothesis, and that's whenever you do a one-tailed test, essentially. Now, if we didn't know the nature, or if we didn't have essentially a directional hypothesis, then we would run a two-tailed. So given this information, I'm going to run Pearson's correlation. So here, we're given a significant p-value of 0.038. So given this particular value is less than 0.05, meaning that it is significant. So here, we can look at our correlation coefficient, and we can determine that it is 0.2666837. So yeah, there we go. So now for part 2 of task 1, we are asked to run a correlation to correlate hours and grades. But specifically, we're asked which correlation should we run. So given that our degree classifications are ordinal data, we have the choices of running a Spearman's rho or Kendall's tau. So we are going, for me personally, I use Spearman's rho. So I ran this information, and we are given a p-value of, is this the right one that I was supposed to run? Yeah, this is the one. Given our p-value, it is a non-significant value in that it is 0.8981 and it is greater than 0.05. So regardless if there's a negative rho here, negative rho value here, it's a non-significant finding. So yep. And what else did it access? Yeah, so I answered that question. So task 2, going back here. Essentially, we have to use the Chick-fil-A data to answer the following questions. So the first question that we have to tackle is there a relationship between gender and arousal? So we're going to have to run a correlations test between these two values, well, variables. So we're going to run that. So yeah, this is non-significant for us. It has a p-value of 0.2659. This is greater than 0.05, so therefore it's non-significant. So regardless of this, it's not a non-significant value. So now we also have to test the relationship between film watched and arousal. So we're going to run this test. Okay, so for p-value, we do have a significant p-value. So given here, really just move the decimal places like 6 times to the left. So 0.09, 0.009, and so forth and so on. Essentially, this p-value is less than 0.05. So this gives us a significant finding here, well, significant correlation between film and arousal. So the correlation coefficient for this one is 0.683. So that's a fairly strong correlation between these two values. So that's kind of neat. So the next thing we have to do, now we have to find the appropriate analysis to see if GCSE math grades correlate with the first year statistics grades. So we have to remember the variables that we're dealing with. So for this particular correlation, we're going to run Kendall. Well, I ran Kendall. So yeah, I'm just going with Kendall. So we're gonna run it. Oops. Well, yeah, this is great. But if we want some more detail, so whenever we run that command, we get a significant p-value of 0.01465, and this is less than 0.05. And this gives us the tau value, well, correlation value, if you will, of 0.359614. And that's it. Oh, wait. No, it's not. So we have to, so one or two tailed. So essentially, given the information that we have, we're looking to see if there's a relationship between math grades and first year statistics grades. So for this, let's see. Make sure there is. Okay. Okay. No, stay back there. Oops. Finish off for a second. Okay. So essentially for this test, we run a one-tailed test. We run a one-tailed test. Given that we're thinking, that the student is thinking there is a positive relationship between stats grades and your GCSE grades, what have you. So more details. Yeah. So here we have a significant p-value of 0.01465. So given that our p-value is less than 0.05, we do have a significant correlation between the two. Yay! And that's it.